Hello, this is Module 5, Video 14. This video is about our metronome action. So we're finally in a point where we've got sufficient low-level actions, if I can call them that, where we can start composing these low-level actions into more interesting high-level actions. And the metronome action is one of those higher-level actions that we're going to build out. So let me start by creating the files. Right, so the idea of a metronome action is you would give it a set of ticks, if you will, of where, when we want to hear a tick or a bell as per, a standard metronome. So it's a timekeeping action that you would use for a lot of exercises where you just want some kind of audio feedback of whether you're doing stuff in time or not. So you would give it that information, and then when you execute the action, it would, use either the wait action to wait until the next tick or the audio action to play the next tick. So let's start by fleshing out some simple tests here. Okay, so a few things we're checking here. I mean, as I mentioned, we need to use the audio service and the delay service. So we know our constructor is going to need to take them, and we are checking that those arguments are not null here. The other thing we're going to need to know is when to tick, when to play some audio feedback, and perhaps what I'm thinking is we'll have two different types of audio feedback. You've got your standard kind of clicking noise, and then you've got the bell, which you might want to play every now and then to kind of synchronize where you're at. So maybe at the start of each rep you've got a bell sound, and then you've got the clicking sounds at specific points within the rep. So in order to encapsulate that information, we need to take some kind of data structure, which I've called metronome tick here. I'm just going to create that alongside our action, just so we can build. And that will tell us not only what type of tick we want, but also how long to wait before playing that tick. But we'll get to that when we get to those tests. Right now I need to fix this constructor. So now we should be able to build and make sure our tests fail. Okay, they are. So let's fill in that functionality. Okay, that should suffice to pass those tests. Cool. So let's move on to duration then. Okay, so here's a couple of tests. First of all, we make sure that the duration is 0 if we've got no ticks at all. And secondly, we've got this more interesting test here where we do have 4 metronome ticks. We're going to need some kind of enumeration or something to tell us what type of tick it is. So there'll be click and a bell. And in this case, we don't actually care which type it is, so I'm just specifying click here. And normally I wouldn't have written this straight up, but we know we're going to need it, so, and in the interest of saving time, I'm just going to define it straight away, rather than waiting for the test to flesh that out. But the other thing we pass through here is how long to wait before playing that tick. In the first one, we don't wait any time at all, and then a second later we'll play the second one, and then 2 seconds after that we'll play the third one, and then 500 milliseconds after the third one we'll play the fourth one. So the total duration here is obviously 3.5 seconds, which is what we're testing here. So let me get this to compile and then make sure our tests fail. So this is a very simple record type. What I've just decided to do is to make the period before the more important piece of data. So the constructor takes that first, and then it takes the type second, and it defaults it to click. So that can make our tests a bit simpler, because we can remove all this. So that should build and should fail our tests. There we go, 2 failures. So let's implement the duration behavior. And there we have it. Very, very similar pattern to what we've seen before. Just summing up the period before in the ticks, defaulting if empty in case there's no ticks. And now a test passed, so that's cool. So let's move on to the execution logic and start with some tests. Okay, so the tests I've added here, first of all, just make sure the context is not null per usual. But more interestingly, this execute async composes the appropriate actions test. Basically what I'm doing is I'm hooking into the 2 methods on our services that will get called. So play async on the audio service and delay async in the delay service. And when that gets called, I'm just adding an entry to this list of strings that tells us, what actually occurred. In this case, played audio resource and then the resource name. And when a delay is instigated, I just add this delayed for, and then however long we delayed for. Alright, and then I create a bunch of ticks, and I've made sure to use each tick type. So we've got a couple of bells, a couple of clicks, and I've also defined a none type, which may be useful. I was just thinking you might want to have a delay in there and then not have any click at the end of it. Don't know. Maybe yeah, I think that would be useful in certain scenarios, so I've put it in there for now. And of course the idea is if you've specified none, then it doesn't call into the audio service at all. So what we're expecting here is, two entries in our list here for each item, except for the last tick, because that's got no audio feedback. So that's what I'm asserting here. I'm not sure I've got the formatting correct here. We'll find out, I guess, once we've implemented this. But you can see I'm asserting that we've got specific delays, and then between those delays we've got specific audio resources. And again, I'm not sure if this will be the actual audio resource name, but that's what we'll use for now, and we'll change it later if we have to. So let's see if that runs and fails our tests. Yep, cool. So both failing. So let's work on the implementation of this. Okay, so there's our implementation. We are looping over this getInnerActions method and then awaiting each innerActions execution. So the important part really is this method, which loops over our ticks and gets us a wait action for that tick using the period before. And then if the tick type is click or bell, then we also yield an audio action with the appropriate resource. So let's see how we go running that, testing that. Okay, so we've got more actions, or more, we've got more actions performed than we were expecting. So I've obviously overlooked something here. Let me just set a breakpoint. And Xamarin Studio's debugger is being completely useless as per usual. Okay, I'm back. Sorry about that. So what I've found was, and this may have been obvious to you as you were watching, if you recall, our wait action is a bit intelligent in the sense that if the remaining delay is 0, then it will skip over any call to delay at all. But not only that, but it also chunks the delay, which was kind of the one of the really strong requirements for the wait action, was that it didn't do the wait all at once. It would chunk it up into our maximum delay time, and that enables us to keep the user interface updated whilst the delay is occurring. Of course, I didn't take that into account in my test, so I had a delay of 2-3 seconds, and of course that would be chunked up into 2 or 3 separate calls to delay async on the service. So what I've done is change my test accordingly. For starters, I've changed these times here to all be sub-second times, sub-second delays. I'm not at all happy with how this is tied into our implementation of wait action. Just to be clear, I'm not happy with this, but the alternative, as I see it, is to kind of expose higher level information from our metronome action so that instead of instead of hooking into these service calls here, we would hook into an observable on the metronome action, which says what, roughly what it's doing. I'm delaying for 5 seconds, or I'm playing some audio event. I'm not going to do that just because it feels like I'm doing it just for the purposes of tests, which I really don't like that kind of pollution of the design of my code just to kind of facilitate testing. So I'm going to leave it like this for now, but any suggestions are welcome if you've got a better idea of how to tackle this particular design problem. But as you can see, we're now only expecting 8 actions to be performed, and we start with an audio action, not a delay, because the first delay is 0. And then, of course, the format for these is a bit gnarly, but there you go. Now, the only other thing I noticed here was I forgot to call continue on any context here, which we can totally do because we're in a model. So I'll add that in, and then let's just make sure our tests run and pass. There we go, all passing. So there we have it, our first higher level action. We've got 2 more to do, and they'll be simpler than this one. So see you in the next video. Bye.